Well, this is it. My third and last Fluke 8200A-05. And get it out of this box one-handed. There we go. Got a scratch on it, never been used. Got to get the styrofoam off of it. And we had a rubber band disintegrate on us in the packing, so I'm in the process of cleaning the test leads up a little bit to get the dissolved rubber band off of there. But other than that, it's in really good shape. Had a very hefty pack of desiccant in there, which kept the unit very dry and kept it from corroding. So I expect it to be in perfect shape. And we're going to test it in just a minute. Okay, we've got the Fluke hooked up in parallel with the Keithley, which is a 4.5 digit unit. I'm using it as a reference. I've calibrated the Keithley utilizing this analogic voltage reference. Voltage reference provides me anything in increments of 100 microvolts up to approximately 11 volts. So anyway, right now we've got 190 millivolts selected, and we're gonna put that 190 millivolts on the 2 meters, which right now are reading 0. And what we see is that both meters are reading 190, give or take a millivolt. It's normal for the last digit to be off by up to 1. You'll notice that on all the specs it'll say plus or minus a digit usually. And then on the Fluke it is plus a digit. So anyway, 190 millivolts we're reading. That's accurate. And let's go ahead and go up to the 2 volt range and we'll read the calibration voltage there. According to the manual, we want to read, okay, we got 0. We want to read 1.9 volts on the 2 volt scale. And we are seeing 1.901, yeah, give or take a 1 count. We're there on both units. Okay, let's go ahead and we'll take it back down. All right, and let's go ahead and put in 1 millivolt, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Let's go to the hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Let's go to the 1/10 of a volt. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's a volt. 10 tenths is 1 volt. Okay, let's go ahead and we can do 1 volt on this scale, and then we could bring it up 1.9, but we're going to go to the next scale. We're going to read volts. There's 1. Oh, keep these over range. I forgot to change it. 2. 3. 4. 5. 6. 7. 8. 9. 10. And let's go ahead and alright, and then we will go up to the 200 volt. Let's see, we're on the 20 volt range right now. Let's go check the 200 volt range. We see 11 volts, and if we go to the 1200 volt range, 11 volts, give or take a count, which is standard. So we're reading our DC voltage quite accurately. I'm quite happy with that. And we're going to set up to measure resistance here in a moment. So I'll be right back. Okay, we've got the Fluke hooked up to measure resistance here. And let me point out that anything that you see on the display, we've got this clear acetate covering the display to protect it, to keep it from being scratched. I'm not going to remove that because I want the buyer to be able to remove it, and then if he scratches it, it's up to him. But I'm trying to protect it right now. So we have we're in the ohms position. We're measuring kilo ohms. We're on the 200 ohm scale, and we are going to connect a 100 ohm 1/10 of 1% resistor, and we are reading 100 ohms. Okay, let me switch resistors. Okay, we are reading a 10,000 ohm 0.01% resistor, 0.01, and we are reading 10,000 ohms to within 0.01 count. Read that accurately. Let's go ahead and change this again. Okay, at this point we have a 475,000 ohm 1% resistor. And we are reading 475, give or take a count. So that read that accurately. Okay. This is 100,000 ohms. I missed it earlier. 100,000 ohm resistor, 0.1%. Right on the nose. And for this one, I need to kick up to the 20 megohm scale because we want to read 10 megohms. And there is a 10 megohm 1% resistor. We are on the 20 megohm scale. 10.09, 10.1, whatever. Let's read that accurately too. So we've read from 100 ohms up to 10 megohms, 10 million ohms accurately. Let's move on. Okay, it's almost unimportant to do this step since we just did the precision resistors over the scale, but this is a decade resistance box. The resistors in here are all like 0.5%. And right now we are on the 1 megohm. We're reading 1 megohm on the 2000 kiloohm scale, and I'm going to take it down one step at a time. So we're going to go down 100,000 ohms, so we'll be 900,000, 800,000, 700,000, 600,000, 5, 4, 3, 2, 1. Okay. And then we are going to change scales. We are now on the 200,000 ohm scale, and we are reading 100,000, 90, 80, 70, 60, 50, 40, 30, 20, 1. Okay, we're going to go down to the 20,000 ohm scale. We're reading 10,000, 9,000, 8,000, 7,000, 6,000, 5,000, 4,000, 3,000, 2,000, 1,000, and we go down again. We're on the 2,000 ohm scale, reading 1,000 ohms, 900, 800. Again, these are 1% resistors in series, so we've got a little bit of extra resistance here, but not a problem. 700, 600, 500, 400, 300, 200, 100. We'll go down to the 200 ohm scale. There's 100, 90, 80, 70, 60, 50, 40, 30, 20, okay, and we've got 9, 8, 7, 6, 5, 4, 3, 2, and 1, 0. So we've just stepped down from 1,000,000 ohms down to 0 ohms in decade steps. So just did that because it's fun to watch and it gives you an idea of the linearity of the thing. It's quite accurate through over the entire range, and we're going to go ahead and take a look at DC milliamps now. Okay, we're all set to read on the DC milliamp scale right now, and what we've done, we've connected a 10K 0.1% resistor or 0.01% resistor in series with a power supply. Variable power supply is feeding into that resistor. Then we're taking the output of the resistor and we're putting it into the meter and taking the other side of the meter and going back to the power supply. So we're in series with the meter and the resistor. Then I am reading the voltage drop across that resistor with my reference voltmeter. So if I can read the voltage across that resistor and I know its resistance accurately, then I know the current going through it accurately. And that's what I should be displaying. So that's the theory. I am right now reading 0.2 volts across a 10,000 ohm resistor, which would be 20 microamps. And I am reading on the 200 microamp scale, I am reading 20 microamps. Okay, if I was to raise my voltage up to, say, 1 volt. Well, that's actually pretty close. 1.0017. So let's go ahead and do it. 1.0017 0.17 divided by 10,000 says I should have 100 microamps, and I am reading 100.3. Alright, it's about as close to 2 as I can get, and 2 volts divided by 10,000, and I'm getting 200 microamps. So that's 0.2 milliamps, it's 200 microamps. So that's correct. Let's go ahead and raise ourselves up to 10 volts. Alright. Pretty dang close. We're going to take that as 10 volts. And 10 volts over 10,000, and we're getting 1 milliamp. Alright, we've changed our resistance to 100 ohms, 1%, and we have a drop across that resistance of 1 volt within a millivolt, and we are drawing 10 milliamps to within 1 or 2 hundredths of a milliamp. So we are reading it accurately. This is on the 20 milliamp range. All right, we have now switched to a 2 ohm, 1% resistor. We are reading a voltage drop of approximately 0.2 volts. All right, and we are getting 101 milliamps. And again, that's accurate to within our tolerance for the resistance and the voltages we're measuring. So we've measured all of our DC milliamp ranges quite well. All right, we are now set up feeding from a generator, signal generator. We are feeding in a 60 hertz signal right now, and we are getting a 0.5 volt reading AC on this Fluke, and we're getting an identical reading on the Keithley, 0.499, give or take a millivolt AC. Let's go ahead and see if we can kick it up. All right. I am reading 1.054 on the Fluke, 1.051, and 5.3 down here, 5.2, 5.3. So within a millivolt or two of each other. And then let's go up to the 20 volt range. And we'll kick this thing up maximum. And let's see if we can get approximately 5 volts on the Fluke. And 0.98 on the Keithley. Okay. Let's go ahead and turn up the frequency. We are now at 600 hertz. I'm getting 10.39, 10.4, 39, 38, 39, 4. And I'm getting 10.36 on the Keithley. So again, within a few hundredths of a millivolt. Let's go ahead and Kick ourselves down around 5. Okay, I'm reading 5.15. And the Keithley's 5.14. In fact, we're reading 1.4 on the Fluke right now. Keithley's 1.4, so we actually are matching. Okay, let's go ahead and kick ourselves up to 6,000. I'm at, I don't know if you can see that, but I'm at 6,000 hertz on the generator. And we are reading 5.17 on the Fluke, 5.14 on the Keithley. Let's go ahead and turn it up to 60,000. Now at this point the Fluke should start to drop off because it's not meant to read this high. But we are reading 5.07 to the Keithley's 5.29. The frequency response on the Fluke is only supposed to go up to 20 kilohertz. So at 20, this would be 20. I got 5.15, and the Keithley's reading 5.15. So the Fluke is accurate to within its specifications up to 20 kilohertz. Alright, thank you. Okay, we're using the same trick as we used for the DC milliamps for the AC. Only our voltage source is the AC signal coming from the signal generator, which right now is running at about 60 hertz and is providing about 1.9 volts across this 10K resistor, and it's flashing between 189 and 19. And our resulting current is 189 to 190 milliamps. So we can reduce our, or let's go ahead and raise our frequency up to its upper limit, which would be about 10,000 hertz, and that would be 10,000 hertz would be right about there. And right now we are still reading, we got 1.91 volts across a 10,000 ohm resistor, and we're getting 189 milliamps, and 180, if we're between 187.9 and 192, we're within spec. So we are right on the, within a milliamp or so, we're accurate. That's very good. So then let's go ahead and reduce ourselves to the microvolt range, microamp range. We're going to go on the 200 microamp scale, and we're going to adjust ourselves for 100 and see, it would be 1.9. Alright, we are 1.91. Wish I could get at that last digit. 1.90 to 1.91, it's flashing, and we're getting 189 microamps in response. And if we're between 187.9 and 192.1, we are right within spec, so we are almost perfect. So we're reading AC milliamps perfectly from between 189 microamps up to 190 milliamps. All right, I think we're done with this. I haven't got anything to test the 10 amp input with, and but I have no reason to believe that it wouldn't work. So finishing up here, let's take a good look at this unit. I'm going to turn off the supplies. The unit is scratch-free, of course. Nice finish. Sort of a seafoam green. Nice looking scratch-free front panel. That tape can be removed and you'll have a beautiful lens. It's a very nice looking meter. Performs excellently, and it was everybody's dream back in the early 80s to have one of these. And now you can have one. I've got one. Very pleased. So enjoy. Be lucky on your bidding. Good luck, guys. Thank you.